welcome back to Math Video Tutorials, and thank you for tuning in this exercise. I will show you how to answer this question here. We need to find the value of sine 2a when we are given the value of sine a, and sine 2b when we are given the value of cos b as well. All right, so first thing you need to do is to rewrite this sine 2a in terms of a single angle, like this one here, and using the formula, the double angle identity, this will give us 2 sine a cos a. So this is the definition of sine 2a is twice sine single a times cos single a. Now the sine a, we got the its value, which is here. So let's replace it or substitute it. So that's 2 times 5 over 13 and times cos a, which we will need to somehow work out. All right, so first let's do this calculation. 2 times 5 over 13 will give us 10 over 13 cos a. Now we've been given some information regarding the angle A, which is an acute angle in the first quadrant. So we expect the angle A between 0 and 90 degrees, of course. We expect the sine A as a positive, of course, as it is given to us here. And also the cos A will also be positive in that quadrant. In fact, all the three trig functions, the sine, cos, and the tan, are positive in the first quadrant. So our angle would be, of course, if I draw a unit circle. So this is the unit circle, and my angle A would be in the first quadrant here. So let's draw it or sketch it. So this is my angle A. Now if I draw a right angle triangle to obtain the opposite of the angle A. Now the opposite is phi, because as you know, the function sine is opposite the side to the angle divided by the hypotenuse. Our hypotenuse is represented by the radius of this unit circle. So let's label it as well here 13. And the hypotenuse, sorry, the opposite is 5. So if I will just sketch the right angle, if I was sketch the right angle here, just to illustrate better, to have a better illustration. So this is my angle A. This is the opposite side 5, and this is the hypotenuse 13. All right, so I need to work out the adjacent here. All right, what is the adjacent? How do you calculate it? Well, since this is a right angle triangle, we can apply Pythagoras. So we're going to say, instead of calling it adjacent, let's call it just x. Okay, let's call it x. So x is going to be square root of 13 all squared minus 5 all squared, and that will give us a value of 12. Okay, so we got our value x, the adjacent. Now it's easy for us to work out the cos, because again the cos of the angle A, or this one here, is going to be 12, the adjacent to that angle, divided by 13. So we can take this fraction and substitute it here. So we will have then sine 2a as a value 10 over 13 times 12 over 13. And that will give us 120 at the top over 169. All right, and that is the answer to part 1. Now for part 2, similar way, you can pause the video, answer it, and then come back to check your answer against mine. So for part 2, sine 2b will be similar to this. The expression of sine 2b will be 2 sine b cos b. And in the exercise, we are being told that the angle B is obtuse. So it's going to be in the second quadrant, right? Between 90 degrees and 180 degrees. So we expect the sine to be positive, and the cos B is negative, as it is given to us here, is a minus or negative 3 over 5. So we got the value of cos B. Let's substitute it here into the expression. So we'll have 2 times cos B first. We can switch them around, no problem. Minus 3 over 5 and times sine B. And we do a bit of calculations here. So 2 times negative 3 is negative 6 over 5 times sine B. So we need to work out the value of sine B, which we expect to be a positive, because we know that from the cast diagram. So my angle B will be here. If I could, my angle B will be this one here. It's going to be all this, of course. The angle B, you always measure from the positive x-axis. And the angle we're looking at is this one, because this angle here, the sine B of this angle of B, is going to be given by the vertical or the y coordinates. So it's going to be by this vertical here. All right. So if I draw the right angle triangle, it will look like this. So this is my angle B. The radius is the same because we are using, sorry, I apologize, the radius is not the same. I should have put in a different circle, but never mind, we're just illustrating here, nothing accurate. So this is the radius 5, which represent our hypotenuse, and the value of the adjacent, because cos B is calculated using the adjacent, which is minus 3, and the hypotenuse, which is the radius of the circle, in this case is 5. So to work out the sine of B, we need the vertical, or the opposite to the angle. What is the vertical? Let's call it opposite, O for opposite. So again, O is going to be square root of 5 squared minus 3 squared, and that will give us, of course, square root of 25 minus 9 is going to be square root of 16, and that's going to be 4, of course. All right. And to work out sine B, this one here, we just do sine B is equal opposite, which is 4, divided by the hypotenuse, which is the radius of our circle, which is 5, of course. So that is the sine B. All we have to do now is just substitute it into this calculation here. So we're going to say sine 2B is equal minus 6 over 5 times 4 over 5, which will give us minus 24 over 25. And that's the answer to part 2. And with this, we complete this tutorial. I hope you have find this video tutorial helpful. Thank you for watching and take care.